Today's lesson is over quadratic attributes with domain and range. Some things to remember about your equations. If in standard form your A term is positive, your graph is going to open upwards. It's going to look like this. A helpful hint is that positive people smile. So if A is positive, your graph is going to look like a smile. When A is negative, the graph opens downward. Negative people frown. So when you have a negative A, your graph is going to go downwards like a frown. Keep in mind that both graphs continue infinitely in the direction that they open unless otherwise stated. Another important thing to remember is as they open, they're going to continue to get wider. So when we're talking about the domain and range of parabolas, for domain, as the graph extends up or down, it's going to continue to get wider as it goes. So that means it's going to continue on and on forever in both directions going side to side. So domain of all quadratic functions is all real numbers. For range, every quadratic has either a maximum or a minimum. And at that maximum or minimum is where our threshold of the range exists. You can crop a picture at the vertex going horizontal and leave either the top or bottom unused portion off. If a graph opens upward, it has a minimum value. So when you crop it there, we're talking about the values above that. So we're going to use y is greater than whatever our minimum value is. When a graph opens downward, you can crop the graph at the top and all of the values below that matter. So y will be less than whatever your maximum value is. Let's take a look at an example. Number 1, when talking about domain and range, a lot of times we refer to cropping a picture. If you remember, the number 1 rule is you cannot crop arrows. So domain are x values going side to side. I notice that I have arrows on both ends. And since I can't crop arrows, I know that they're going to continue to go side to side. So my domain is all real numbers. For range, values going up and down, I can put a crop across the top of this graph. I cannot crop the bottom because since they have arrows, they'll continue indefinitely going down. So my range is all the numbers less than 6. So y is less than or equal to 6 because my graph does exist at 6 and below. For vertex, we want to find where the graph changes directions. This point here is my vertex. When I write it as an ordered pair, my x value is -2 and my y value is 6. So I have a vertex of -2, 6. Y-intercept is where my graph crosses the y-axis. It happens here at +2. It can be written as an ordered pair 0, 2, or you can also just simply list it as the digit 2. Minimum or maximum, circle 1 and solve. If you remember, a quadratic function has either a minimum or a maximum. This graph has a high point, so it is a maximum value. The highest this graph goes is 6, so my max is equal to 6. If you remember, it's always equal to the y value of your vertex. My zeros are where the graph crosses the x-axis. So as I put a finger on my x-axis and find where my graph crosses, I see that it crosses here and here. I see that my graph crosses at -4.5 and +0.5. So when I write those as improper fractions, I have -9/2 and +1/2. For axis of symmetry, I'm looking for the line that I can fold this parabola in half for both sides to be the same. If you remember, the axis of symmetry always goes through the vertex. It is a vertical line. So vertical lines are Vux situations, so they are x equals equation. But if you remember, the x in axis of symmetry reminds me that it's going to be an x equals an equation. and it's going to be equal to the x value of my vertex. So my equation for axis of symmetry is x equals -2. The next thing I need to do is decide if the a value for this graph is positive or negative. And since my graph is frowning, it is negative. One more example. For a domain, if you notice, I have arrows, so I cannot crop my graph going side to side. Domain for quadratic functions is always all real numbers. For a range, I can crop the bottom of this graph at -4. And since the values are above -4, we're looking for y to be greater than or equal to -4. My vertex is here at the ordered pair 5, -4. If you notice, this problem doesn't have a y-intercept for us to list. I do want you to realize that there is a y-intercept for this graph. And if we had it in our calculator, we would zoom out until we see where it crosses. But for the portion of the graph that we're given, we cannot see the y-intercept, so we're not going to answer that part for this question. This graph has a low point, and we consider low points a minimum. Remember that minimums and maximums are equal to the y value of our vertex. So the minimum of this graph, or the lowest point of this graph, is -4. Zeros are where my graph crosses the x-axis. So I have one here at 3 and 7. Axis of symmetry is a line that I can go through my vertex and fold my parabola in half to get a perfect mirrored side on both sides. The x in axis of symmetry reminds us that it's going to be an x equals equation, and it's equal to the x value of my vertex. So for this parabola, it's x is equal to 5. Since my graph is opening upwards, it is smiling and positive people smile. So my a value is positive. Looking at the bottom, we want to turn these equations into standard form. As a reminder, standard form is ax squared plus bx plus c. So I need to get everything on the same side of the equation. So I'm going to start by moving this -5. To undo a -5, I +5. And if I do it to one side, I have to do it to the other. Now, if you notice, I don't have any other constant numbers. So there's nothing I can add that 5 to. So my equation now just becomes -x squared plus 4x plus 5. Given that information, I can now find the a, b, and c value. A is the number that is attached to x squared. And since there's a negative sign in front, that makes it a -1. B's value is a +4, and C's value is a +5. We will now go to our calculator and graph -x squared plus 4x plus 5 to find all of its key attributes. Opening up my calculator, I'm going to go to graphs. I'm going to graph -x squared plus 4x plus 5. Using menu 5.1, I can trace my graph. The first point I'm going to look for is my vertex. So as I slide to the side, I notice that my vertex happens at 2, 9. My calculator is also helpful in letting me know that that is the maximum value, but I know that any graph that has a high point has a maximum value. So now back at my problem, my vertex is 2, 9. Knowing that, I can find the axis of symmetry. The x in axis of symmetry reminds me that it's going to be an x equals equation equal to the x value in my vertex. So my equation is x equals 2. Looking for the zeros, y-intercept, domain, and range, we're going to go back to our graph. For zeros, I have a 0 at -1. I have another 0 at +5. So my zeros are -1 and +5, or you can write them as an ordered pair, 5, 0 and -1, 0. Next, we're going to look for our y-intercept. Our y-intercept is at +5. The only other thing I have left to determine is my domain and range. Well, if you remember, domain of this graph is going to continue on and on forever. You can notice that by zooming out. If I zoom out, you see that it still goes on, and as it goes, it's getting wider. So side to side, it's never going to stop. It's going to cross all real numbers. My maximum value for this graph is 9, so I know that the graph will never get above 9. So my range will be y is less than or equal to 9, because all the values below 9 are part of this function. So just a quick recap on that. My zeros are -1 and 5. My y-intercept is 5. My domain is all real numbers, and my range is y is less than or equal to 9. Just a quick reminder that my c value of +5 will always be the same thing as my y-intercept. Next, let's take a look at the factored form. For me to be able to turn this back into standard form, I need to multiply these two polynomials together. So I'm going to start by distributing my x. X times x is x squared. X times -2 is -2x. 6 times x is 6x. And 6 times -2 is -12. When I combine my like terms, -2x plus 6x is a +4x. Since there's no other x squareds or constant numbers to combine together, the x squared and -12 just come down as part of my answer. So now I know my a value in front of x squared is a 1. My b value in front of the x is a +4. And my c value or constant number is a -12. Domain of all quadratics is all real numbers, but I'm going to go ahead and graph this to be able to find my domain, my range, and my zeros. Adding to the graph, I have x squared plus 4x minus 12. Using my trace feature, I'm going to go ahead and find the minimum value to be -2, -16. So when I'm talking about the range, the lowest point on this graph is -16. So all my y values will either be -16 or greater. So we'll say y is greater than or equal to -16. As for my zeros, I have 1 0 here at +2. And my other 0 is here at -6. So my final answer is domain is all real numbers. Range is y is greater than or equal to -16. And my zeros are -6 and +2. Take a look at your zeros and your original factored form and notice the difference between x plus 6 and x minus 2 and your zeros of -6 and +2.